I'm working on arriving in game, trying to get everything set up, so hopefully you all are working all right. Today is February 1st, Monday. We are working on Java, our last lecture of Chapter 3. So let me see if I can join you in game. Go ahead and connect to Eclipse and Saros while we're waiting. I'm logged in there, so if you see me, then you are connected as well. Okay, I panicked a little bit and locked myself out of my VPN. I was worried about setting up the world, and I got a little excited and I locked myself out of the VPN. So I'm trying to correct that problem and get back into the VPN so I can join you all in game. And I'm arriving, and let's see. All right, there we go. I'm arriving in game. I'll be there in 1 sec. Okay, sorry for the delay, folks. I locked myself out of the computer accidentally. So I am here. Let's run through our checklist real quick to get us going because we got a lot to cover today. I'm double broadcasting right now in game and on YouTube. Behind me, I should have YouTube going on the screen. Can someone confirm that YouTube is broadcasting okay?
Yeah, it's broadcasting.
Okay, I'm going to stop broadcasting in game then. Okay, let's see. Let's run through our checklist to make sure that we have our system set up and running all right. And so for our checklist for this class, make sure you're in a quiet location. You guys are probably doing better than I am at this point. Make sure your roommates know that you're in class and so that they can stop doing their tuba practice. Make sure you got headphones put on to isolate echoing from other sources or your computer if you decide to unmute. Turn off notifications on your phone or your computer so you're not getting constant messages from your, say, from your wife asking where the laptop charger is. Um, Shut down any extra apps or browser tabs that you have. For example, the science fiction movie that you're watching on YouTube. Open Canvas so you know what we're talking about when we talk about schedules and things that are due. Fire up Eclipse so that you can look at code today and go ahead. Stand by. I see an error in game. Okay, we should be broadcasting live in Eclipse. It should start with me saying February 1st. Did you not see that? Or did that not come through? Double broadcasting right now in game and on YouTube. Okay, no one's responding, so I'm double checking myself.
Yeah, I'm not seeing the YouTube stream. It's just a like an old video on the screen
Okay, stand by.
that I can like pause and unpause.
Well, it does have DVR. You can pause and unpause it because it's DVR style. But let me make sure it's the right thing. All right, let's see. Shoot, it looks like it reset for me. Okay, stand by.
You know what? I think it's better now because I unpaused it and dragged it all the way to the right, and that brought it up to live.
Okay, and is it me in a box talking actually live today?
Yeah, with the blue sweater.
Okay, great. I'm not going to mess with it then because it seems to be working. Okay, so that's a note that you may be behind live because this is DVRable, but you do want to be live because when we start doing code, you're going to want to be able to see what's happening live. I'm going to go out of game so you're not double broadcasting. All right, but I can still see chat. Okay, so our checklist. Make sure your notifications are turned off. Make sure you've got Canvas open. Make sure you've got Eclipse open and you're connected to Saros. Right now, I am open in Eclipse, and I see a ton of you are already in Saros. That's great. Okay, we'll get there. Make sure you rebake your avatar in game so that we all look and have a reasonable experience with each other. Force appearance update, avatar health. Make sure you go into world and under environment, select midday so it looks like a reasonable time in game. Make sure your draw distance is set to a low number. A little tip for today, if you're interested, you can go, there's an advanced menu, and under it, performance tools, there's something called a lag menu, a lag meter. And the lag meter will tell you about if you're having lag in game, what the source of it is. And you can get it from your client or from the network or from the server. And most of the time when I see lag, it is primarily because of the client, which means your draw distance is set too high. It's a little bit from the network, depending on where you are. But that's an interesting thing you can see. I will show you in game what I'm looking at here. So there are a lot of advanced tools, but what I'm trying to show you in the center of the screen there is the lag meter, and at the top it's saying client. To get there, I went under advanced and performance tools and looked at my lag meter. There. All right. but I'm convinced I kind of know what's going on in terms of the lag. And okay, so make sure you've seen names, make sure that you're in the classroom, and make sure you've got a little dot over your head indicating that your audio and your VPN are connected all right. All right, um, anyone need to talk about logistics or what's happening in game before we switch over to looking at our calendar? All right, let me bring up our calendar. I'm getting a little better at this. All right, on our calendar for today, it is February 1st. You'll see on your calendar, you've got something for class 9, which is today. And that is something to turn in some evidence that you ran a JUnit test, and we'll get there by the end of today. Tomorrow is a Westmont holiday. We have an unusual calendar this year because of COVID response. If you are a first year, this won't seem unusual. It'll just seem like what we're doing. If you are not first year, this will seem a little bit different. Wednesday, you've got a Chapter 3 Techne assignment due, and then Friday, you have a programming assignment due. While some of the Techne questions may reference the graphics application, that's just a general process of learning to work with other code that's been written and learning to work with an interface and learning to work with objects. On the exams and in the programming assignments, I will not bring up questions about the graphics component of the textbook. That's not very important, I don't think, to me, other than it's useful as an exercise in being able to look at interfaces and classes. All right, we are in chapter 3, and let's switch over to a view of Eclipse. And so I've got Eclipse showing here. Let me show on in-world Eclipse. All right, and what I've got is I've got a session. I'm going to start a session for class today on Saros, and we'll go through the process of getting everyone set up. Now, what I would like to say about Saros is that I had some good interactions with folks in office hours. And what that enabled me to do is isolate some of the problems that people are having in getting their Saros sessions synchronized with mine. So if you have a problem where you can log into Saros okay, but then when I share a project with you, you get various kinds of errors after we try it maybe twice, then the problem is probably related to antivirus software or firewall software that you've got, and we'll need to talk during office hours to get that fixed. The problem seems to be that, in particular, the McAfee antivirus software that comes pre-installed on computers that people bought from Costco or possibly other locations is blocking Eclipse's access to the network. And it's not blocking it based on a port, it's blocking it based something about the application settings. So I'm not quite sure how to do that, but in order to fix it, what we had to do is enable Eclipse to have access to the network in order for Saros to work freely instead of being behind a kind of limited firewall. So here comes the project. I just sent it out to everyone who's currently logged in. It is a project that has no classes in it. It is called it's called class 09 0201 for today. There you go. I'm going to move some code into it in a second, but for the sake of making sure that we can synchronize quickly, I just put it in with no code. Looks like several of you quickly connected, and let me just wait. What I'll do is I'll go through and I'll try to connect everyone maybe 2 times, and if we have trouble after that, then we'll try and debug it later in another environment, because I don't want to spend tons of time trying to get us connected here. Today's lecture is being recorded, so you can go back on YouTube and take a look at it. All right. For those of you that are connected, I'm switching over to read-only for you so that you don't accidentally mess up the presentation today. And for those of you whose invitation canceled, the first thing to do is to restart Eclipse, and then I will try and re-add you one more time. Another reminder that as this is all going through, there is a little button on the Saros panel next to where you connect your session with eyeglasses, and there you can put the focus on me so that as I'm editing, your editor is going to move around to wherever I'm editing, so you don't have to worry about trying to find me in the file system as we're editing. All right.
Hi, Professor Carlson. Can you send me the invitation again?
Yep. I'm going to finish going through round 1, and then we're going to do a round 2 and see if we can get round 2 to work. If round 1 didn't work, please restart Eclipse right now so that if that is the source of the problem, it'll be fixed. But when I try round 2. Oh, sorry, you don't see what I'm doing. Oh, let me switch over to what I'm doing. All right, I'm about to start round 2 here. Okay, here I go, starting round 2. All right, add a line. I don't know exactly what happens if I overload it, but okay, that one, I'm not sure. It looked like something failed out of line, so try restarting Eclipse. Ben Fernberg, here you go. Okay, looks like that failed. Ben Ehrenchild, you were on earlier. I'm not sure what happened. All right, Carson. Ethan Vaughn. Josh Fitzgerald. Monty. Matthew Loke. Morgan. Trent. Thomas. And Toby. All right, I'm going to see what you folks are typing over in game. Okay, everything is about the live.
Professor, it said that it was canceled locally.
All right, let me double broadcast here for a second.
Yes, the same thing happened for me. It said the invitation was canceled.
Okay, yeah, I think that if you're getting the invitation is canceled problem, I think that's being caused by interference with a firewall. And so what I'm going to do is let these current invitations play out. And then if you got canceled for some reason, let's connect an office hours, try and figure out what's going on. Okay, so while we're waiting for those to connect, I'm going to move over the code that we had from last time into our new project. Let that all synchronize up. All right, so moving on smartly. Where we were last time was trying to make this example of a bank account class. And in the bank account class, we had several different components. We had an amount, we had a bank account, we had a bank account test, we had amount test. And what we introduced here was the idea of doing JUnit tests. JUnit tests are kind of the focus of what I want to cover today, but I want to finish the code that we had written last time to make sure that we leave that in good shape. So let's zoom in a little bit to our code and take a look at what we were working with. So for starters, we had our bank account class, and this was a class that we were creating in order to try and represent someone's bank account. Their bank account is going to have some money in it, and we wanted to provide a public interface that included things like the ability to deposit money to a bank account, the ability to withdraw money from a bank account, the ability to get the balance of what's in the bank account. And the bank account was our object. Of course, the bank account acts like a recipe. It is something that we could create multiple instances of if we had different people with different bank accounts. And so that was an important part of how the bank account worked. Now, in the past, we might just keep track of the amount of money that's in the bank account by keeping track of a floating point or something. But we know that when we do that, what happens is that we have problems with rounding off. And so we want to eliminate that. So let me just get a little bit of feedback and let me isolate that. Okay. All right, so we want to be able to isolate that. We want to prevent floating point numbers from rounding. And so what I did is I created a second class that was going to be useful for helping us to manage that, called an amount class. And what an amount class enabled us to do was just to keep track of dollars and cents, but to keep track of them as integers to make sure that we can't round them accidentally. We had a constructor which initialized an amount object to 0, but basically an amount is like, it's like a wallet maybe is one way to think of it. And when we created an amount, we could either create it with a constructor that gave it 0, or we could create it with a constructor that had dollars and cents initialized. We have a couple error conditions. We want to make sure that we never initialize it with a negative number, either in dollars or cents. And we want to make sure that at any given time, our class always has an amount of cents, which is 0 or greater and less than 100. Because if we ever have more than 100 cents, we want to convert that into a dollar. So we created a helper class, a helper method within our class called update. And what update does is it runs a loop and says that as long as cents is greater than or equal to 100, we want to fix that. We want to add 1 to our dollars, and we want to subtract 100 from our cents. So upgrade our cents from our dollars. It's like turning in tickets at the arcade. Then finally, we have some getters and setters for dollars and cents. And what we did in order to make sure that the code that we wrote does what we expect it to do is we wrote what's called a JUnit test. Now in CS-10, we looked at tests, and what tests do is they make sure that the code that you're writing meets your expectations, that if you write something and you expect it to behave a certain way, but you don't know that for sure. And so as a systems programmer who's implementing a class, the reason you're implementing that class is so that an API programmer is able to use that class. So as a systems programmer, what you do is you write a test. JUnit test is one particular kind of test, but you write a test acting like you're an API programmer to make sure that as an implementer, you implemented it correctly. And so that's what I've done over here is I've created a sibling class called amount test. And what that does is it goes through, and my goal here is to run every single line of code in the implementation of my amount class and to run it and make sure that we get the right answer for what we expect. So here's, for example, my first test. I just call the constructor and I make sure that it starts out as 0 and 0. I was actually testing this, so that should be wrong. What we expect is that we'll have 0 cents and $0. An interesting thing about writing these tests is that we can actually write the tests before we've done the implementation. And writing that tests is part of the design process because in writing the test, you have to be explicit about what you expect your class to do, and that's expressed through the code that you write for the test. So what we see here is I create an amount object with the generic constructor, the default constructor, and I assert equals. I say the test is that when I get the number of cents for this object, it must be 0. And if I can't assert that this is true, then my test fails and something has gone wrong with my implementation. Here's another test. I'm going to assert that it must be true that dollars is equal to 0 as well. If these two things aren't true, then my implementation is broken, and therefore my test should fail because I have not implemented it correctly. So I can highlight that, and I can run that as a JUnit test. I can run it as a JUnit test. Great. And then what I can see is I'm going to make this big so you can see it. Let's see, is that actually working? I'm looking at what's broadcasting on screen to make sure you can see it. And you can't exactly see it. Let's see. All right, so I'm going to roll back to a bigger view, and I'm going to put my windows back in place. Okay. And what I'm looking at then is down here in the bottom right, I'm looking at the JUnit test results. And what I can see is that because it's been highlighted green, the result of my test was a success. All right, a second thing that I can do is instead of running it as a JUnit test, I can do coverage as a JUnit test. And what that's going to do is it's going to tell me which lines of code actually got run when I run this one test. So what I did is I put my cursor on this test, I right-clicked on that test, and I'm going down to coverage as a JUnit test. I will run the same JUnit testing framework, and I will see what actually gets run. I see that these lines are green, which means these lines of code were run on the right. And I see that these down here, these other tests, they weren't run. They're red. That makes sense because I only asked for this method to be run. Meanwhile, over on the left, in the amount code, I can see which lines of code got run. Well, I called my default constructor over here on the right in line 13. So line 9 ran. And because that called this constructor here, you can see that my superclass call ran. You can see that this line partially ran. It says if dollars is less than 0. And by highlighting it yellow, it means that this line of code ran, but because it's an if statement, it's yellow if only one of the conditions ended up being true. It never tested both conditions. It only evaluated in one particular valence. So in this case, dollars was not less than or equal to 0. So we only tested one of the possible two branches here. We never threw this illegal argument exception because in the test that we ran, dollars was not less than 0. It was 0. Likewise, we ran this if statement once and evaluated one of the conditions. We did not end up running this line because sense was not less than 0. But then we did end up running these two lines of code. We ended up running update. And again, you can see that in update, we partially ran this while statement. We saw this statement evaluate in one direction, the direction where sense was less than 100. And so we never ran the body of the while statement. We just skipped back and ran it. So that's interesting. We can see something different that if I decide to run the second one with code coverage, I'm going to do coverage as a JUnit test after highlighting it and running it in red. What we're going to see is over on the left, the default constructor does not get run. Just this larger constructor gets run. Code coverage is different now. We see on the right, we ran this test. It's green. This one did not get run. We did not end up running this constructor in this test. We only ran this one, and we didn't run all possible paths. We only conclusively ran the lines that were in green. So now what I would like to do is I would like to run all the tests within my class. So I'm going to click on the class name. I'm going to right click on the class name, and I'm going to do coverage as a JUnit test. It will systematically go through each one of the tests that's in my file. As if I look down on the bottom left, switch over, and I open the accordion view of the JUnit test, you can see each one of the method names in my test class that were run, and you can see that all of them passed. They are green here because they passed, and it is green in the code because the green lines ran or partially ran. When I look over in the class that I was testing, you can see that every single line of code got color-coded green, which means something very strong, which means that I executed every single line of code in my class as part of a test condition. And so I can have high confidence that my class is behaving correctly. Not complete confidence, but high confidence, because I have executed every single line of code and validated it on the right that it has worked correctly. All right. You don't have to have every line of code colored green in your test class because, for example, We don't want the fail line to run in this particular test, but you do want every green line to run in your amount class. Let me pause for a second and go over to game and see if there are any questions about that bit before we take it up a level and go to the code that uses the amount class, the bank account class. All right, let's see. Looks like everything in game is about, let's see, doing a double broadcast. All right, double broadcasting for a second, just making sure that everything in game is related to Saros connection. It looks like it is. So I'm going to go back to single broadcast and continue with my classes unless someone's got a question they want me to address about testing in the amount class. Yeah. Sorry, I cut off both my audio. Frank, I heard you ask for another invitation, but what I'm going to do is hold off until after class because the process of just sending invitations and having them fail over and over again isn't getting us to a point where we're getting you connected. What we need to do is address why it's failing, and I don't want to do that in class, but I'm happy to do that after class or in office hours. Um, uh, I'll send you the code though after class to make sure you have a copy of it. Go ahead, Josh. Um, yeah, let me answer on YouTube so for archival purposes. Okay, so Josh asked, what's going on with two different constructors? Is that legit? Is that possible? And the answer is yes. Two different constructors is what we call overloading, overloading a method. In Java, you're allowed to overload any method you want. And what that means is you can have a method with a particular name, and as long as it has different sets of parameters that are called, you can write it in different ways. And so what we have here is actually two different constructors. And these two different constructors can be called in two different ways. So they can be called in two different ways. You can call a constructor once with nothing in it. Here's an example over on the right of doing that. We've called the constructor and we've created an amount object, and the contract for that is that it will get initialized with with $0 and cents. So let me make that clear by putting in some comments because our code should have comments. I'm going to use something called JavaDoc comments, and JavaDoc comments are kind of nice because you get some support from Eclipse from writing them. And the way that you do a JavaDoc DOC comment is you do an extra star. So if I do double star like that, I'll get a little block and I can say construct an amount, I'll capitalize it, an amount object with $0, make it so you can see it, $0.00. So that's one way you can create an amount object, and you can see this happening over here on the right. Another way you can create an amount object is by specifying how much money is going to start in your account rather than assuming 0. And so down here, this is an example of that constructor. So I'm going to construct an amount object with a specified balance. In dollars, the starting dollar amount and the starting cents amount. All right, so now I have two constructors that I can use that do two different things. So the answer is yes. Okay, so that was one question. Can you have two different constructors that have different parameters? The answer was yes. There's also another, there's an sort of an implied question, which is what the heck is this line? What is line 13? That enables one constructor to call another constructor. As you know, this is a self-referential reference. It's used the same way as the self-reserved word in Python. And when you use this particular way of calling code, this with a different set of arguments, what you're doing is you are implicitly calling, let me specify this for you, amount, a different constructor. You're just calling the constructor with a different set of parameters. And what this enables one to do is it enables one to, here, I'll move that over there. It enables you to reuse code. So I don't have to write the constructor twice. I just say, well, amount with no parameters is the same as calling amount with 0, 0. And so this line 13 ends up calling line 22 with parameters of 0 and 0. So it's just double counting. All right, so that's two questions. One is, can you have two different constructors? Yes. Second question is, what is line 13 doing? That's just making another call to a different constructor. And there's a particular way that you do that, and that's this syntax. The third question is, what the heck is super doing? Super is initializing the parent class. So in Java, all objects have a parent class, which is called object with a capital O. It is like the universal parent class in Python as well. This is just good programming style. My superclass actually isn't doing anything, so I don't really have to have that in there. That's kind of optional in this particular class, but it's good programming style, so I leave it in there. So let me see if that actually addressed all the questions. Josh, did that address all the questions? Great. Okay, so let's save all that and let's go back to our bank account class. So we have our bank account class that uses our amount as well, and we have a test for that. So just like our amount got tested, we can also test our bank account. So let's go over here and test our bank account. It's colored red because the last time I did code coverage, none of this got run. I can see that my face is covering this a little bit, so let me, what should I do here? I'm just gonna let it be. Maybe I'll hide my face for a sec. As much as I love my face, we'll hide it. No, we won't hide it because it's too much work. All right, we're just gonna work with it. It's color-coded red because last time we ran a coverage, none of this code got read. I'm gonna change the lines of code to make the red go away, and then I'm gonna undo the change. All right, so the first thing that I wanna do is I wanna check my bank account, not the amount, my bank account to make sure that the functionality of bank account works. Oh no, first thing we gotta do is we gotta figure out, we have some implementation here we didn't add. So we saw that in order for us to be able to do a deposit and a withdrawal, we have to have the ability to add an amount to our balance and subtract an amount to our balance. The amount class needs to be augmented so that we can make all this work. So what we're going to do is we're going to add that, and I'm going to leverage Eclipse. I'm going to do Command 1, get some recommendations for how to change this, and it's the first option is to create a method called add amount and type amount. That's exactly what I want to do. So I selected that, and I jumped over to the amount file, and what Eclipse did is it wrote a method for me that I just have to implement the implementation for. So what I have is I have one object, this, and I have another object, A, and I want to make this object that has dollars and cents be equal to what this was before plus the amount that was brought in by A, because I'm adding the current object's balance to the current object's amount to what was just passed in. And so the way I'll do that is I'll just say that this dot dollars plus equals a dot get dollars. So I'll add the amount of dollars from the other amount. And I'll say this dot cents plus equals a dot get, never go over 100. So we just need to make sure that we update our cents, our dollars and cents. So at the end of adding this up, we're going to update it to make sure that if we have cents over 100, it gets properly accounted for. I also want to think about corner conditions. We know that amount is never going to have negative numbers because that's ensured in the constructor for amount. So we know we're not going to get any negative numbers. So we know that because we started with non-negative numbers and we're adding non-negative numbers, we're not going to end up with any negative numbers. So I don't have to worry about that. So my update should work fine. Now I've added a new method to my amount class. So I want to make sure that my amount test is updated as well. Put the test over on the right. So I'm looking at the class under test on the left and the testing code on the right. I'm going to right click on the test. I'm going to rerun that coverage of that JUnit test. And what we should see, why is it not letting me run it? There we go. That my tests are running all my previous code, but I have no test that leverages my add method because none of my tests did that. And what I want is I want a test that's going to test to make sure that add does the right thing. So let's add another test. We'll add a test down here at the bottom. We'll call it add test, test amount 6. The name doesn't matter a whole bunch, but let's create one amount. Oops, let's create one amount that uses the default constructor. And so we start with 0 and another one that has 150 in it. And let's create a third one just to be exhaustive. Let's have this one be $2.01. And what we want to do is we want to say, start with A, and we want to add B to it. And now what we want to assert is what we expect the answer to be. So we expect the answer after we add A and B that the number of dollars in A better be equal to 1. And we also want the number of cents that's present in, oh, no, I'm sorry, that should be 2. And the number of cents that's equal in A should be equal to 50 cents because we've taken an amount with 0 and we've added $1 and 150 cents to it. And after we add those together and do our cents update, we should better have 250. That's our expectation. And so if our implementation doesn't do that, there's a problem with our implementation. All right, now I want to continue doing some work. In addition to adding B, I'm going to add C to it. After I do those checks, I'm going to update the state again. And now I'm going to assert that A better be different. I've added $2.01 to that. So now A better be equal to 4, and the cents better be equal to 51 cents. And furthermore, I'm going to add a test to make sure that B and C didn't change along the way. So I'm just going to make sure that when I get dollars and cents from B, that it better be equal to 250. And I want to make sure that C is equal to $2.01. So to make sure that nothing changed as well while I was doing that test. I run that, and now I'm going to right click on here, do coverage as a JUnit test. See that my add works okay. Great, my test passed. I look down here, I look down at the lower left to make sure that my test passed. All my tests, or the tests that I ran passed, and you can actually see that this one test is running a lot of the code. But mainly I'm concerned about the add method. All right, so now I also have in my bank account, I also need to have a subtract method. So I'm going to highlight that. I'm going to do command 1. I'm going to ask Eclipse to write my subtract method. It stubbed out the subtract method for me. Now I need to add the code for that. And I'm going to keep it slightly similar. I'm going to just say that dollars is going to be dollars minus the amount that's passed in, and cents is going to be equal to the cents amount minus cents. But the difference here, and then we'll update it. The problem now, though, is that we could possibly have a negative amount in our amount. And we want our amount to never go negative. That's a design decision that we're making. And so after we do the update, we're going to check to make sure that none of our amounts are 0. And if they are 0, then we're going to throw an exception. We're going to say, hey, something broke. You should have checked that before you subtracted it, API programmer. And so I'm going to say, I'm just going to make a method called this check for negatives. And it's going to check to see if the objects that I'm calling it from has negative balances. And it'll throw an exception if it does. And I'm going to use Eclipse to help me write that. It's going to create that method. You can see it created a private method here for that. And the thing is I'm already actually doing this. I'm doing this in the constructor. And so rather than rewriting all my code, I'm going to come up here to my constructor where it checks to see if dollars is less than 0 and cents is less than 0. I'm going to copy this code and I'm going to put it down and check for negatives. So if dollars is less than 0, I'll go ahead and put a this in for those of you who feel more comfortable like that. And I'm going to go ahead and put a this in, although it's not necessary. If either one of those is 0, it's going to throw a new illegal argument exception. I don't like having duplicate code in my code base. Here's some duplicate code. So instead of running this, running the code that's here, I'm going to remove the code that I just copied. And at the end of doing my initialization and my update, I'm just going to check for negatives. And so if I created an object that has negative amounts, I will check for negatives and throw an exception. So the same code is being run in the constructor and in the subtract, and if that recognizes a negative number, it'll throw an exception in both accounts. I want to make sure that that change didn't break any of my existing tests, so I'm going to go to my class and I'm going to run my tests again, make sure that my changes didn't break anything that was previously working. Down here in the bottom left, everything passed, so that's good. As I look up here to see code coverage, we can see that all my code got run except for the subtract method, which is the new method that I just created. And I don't want to release code that I haven't tested, so I'm going to write another test that tests my subtract. I'm going to grab my 6th test and I'm going to cut and paste it. I'm going to change its name so I don't have a conflict with the name. Again, I could, if I added a parameter, I could overload this name, but I don't want to add a parameter. And what I'll do is I'll start with B, which it should be $2.50. I'm going to create another one that's $2.01, and I'm going to subtract from B. I'm going to subtract C, and I better find that after I do that, $2.50 minus $2.01 better be $0.49. So I'm going to assert that that's true, and I'm going to assert that nothing changed in my C object as well. Right click on that, do coverage as a JUnit test. I'm trying to show you the results of that. The bottom left here, you can see that I got coverage. All my tests passed. I'm good to go. And if I look over here on the left, we should see that this is green, but someone in Saros has got it highlighted, so we can't see that it is currently green. But that's okay, it is green. Go back up to my class. I'm going to run all of my tests to make sure that I haven't broken anything. Everything that was there and everything that I added should all pass. My JUnit test at the bottom left running. Waiting for that to happen. Got code coverage. All my tests pass. I have high confidence in my code. Now I can go back to my bank account class and finish what I was doing. My bank account class has all of the methods implemented. I want to test to make sure that my bank account does what it's supposed to do. Let's see, what am I doing in my bank account? I'm testing my constructor. I'm constructing the deposit here. Here I'm testing the deposit and the withdrawal. Why am I not adding any new code to the test? Well, that's because when I wrote my tests before I had done the implementation. And in the process of doing the implementation, I had to write additional methods for amount. But my tests are still good because they are describing the way that my class should behave, even though it didn't at the time. So now let's see what happens if I right-click on my test and do coverage as a JUnit test. Hope for the best. Great. So I look down again at the output of my JUnit tests. You can see down here that I have run 3 tests from the bank account class. I can see over on the left that all the code in my bank account has been executed. All my tests pass. If I look to my amount class, I can see that, well, I can't see it because it's highlighted right now by someone. But I have really high confidence now that I've done a good job of writing my bank account class because I have written my methods, I've provided a public interface. As a systems programmer, I've written my public interface, I've implemented my system. I have also, as a systems programmer, written tests as if I was behaving like an API programmer, and I validated that some basic behavior that I expected from my design is holding true. And I did that with a bunch of assert statements. So let me pause for a second. I want to go to a slide deck now, but I want to see if you have any questions about that before we move on. Okay, let's see. I do see a question. Landon says, why don't you need public in front of amount? You mean in the constructor, perhaps? There is a default there is a default visualization. I should have put public in there to be explicit, but if you don't put public in there, then there is a default visibility depending on who's calling it. Safer to put public, yep. Safer to put public and be explicit about what you want rather than rely on the defaults. Good question, Landon, thank you. Okay, let's shift gears and talk about JUnit testing a little bit academically. So what I'm doing now is I am going to play a slide deck. There we go, I'm playing the slide deck, and now in code, and let's see, now I need to switch over, so I am showing that. Stand by. I am displaying slide deck. Slide deck, there you are. Good, and rolling over to slide deck. Let's roll over there. I don't want my face blocking that. Let's just. Sorry, I'm monkeying around with the presentation here so that we don't have unnecessary blockage of slides. Okay, let's see if that's a little better. Okay, let's go with that. All right, so let's talk about JUnit testing more academically. All right. JUnit testing is part of the process of testing, generally speaking. So when we do JUnit testing, what we're doing is we are validating our code. We're making sure that it works according to specification, and it is something that you do as a developer in order to make sure that your code works for someone who's going to use your code. So you are the developer, you are the systems programmer, you are doing the implementation, but the reason why you're writing a test is to make sure that the person who's going to be using your code as an API programmer gets the expected behavior. We use the word unit testing instead of just testing because what unit testing is testing a single class or a single method. There are other kinds of testing that you can do, but unit testing means testing the behavior of just a single entity. Typically what we mean is class. It is crucial to professional software development. You should never, ever, ever write code and release it to anyone and subject them to your code without writing any kinds of tests. And most companies, most software development companies have this built into their software engineering process, so you can't do that. In fact, not only do you have to write tests, but you have to have more senior developers look at your code and make sure that they agree, even if it passed the test, that it is well-written code. Because you can pass tests and write inefficient code also. So the primary reason we do this is to make sure our code meets specifications. Is your code doing what you think it should do? We also do it to make sure that our corner cases are covered. Will our code still work with weird input? And you could see me doing that when I was writing the tests as I thought through the behavior of how I wanted my class to work with negative amounts. And in the process of thinking through that, I had to explicitly say, what happens when you try and create a negative amount in a bank account? And my design decision was, rather than allowing negative amounts in bank accounts, which is possible, you could do that as a design, I decided instead that I wouldn't allow that and I would throw exceptions. That has to be part of your specification, and then you have to test to make sure you're meeting your specification. At the end of the day, fixing your code before you deploy it is so much easier than fixing it after deployment. It is so much better to catch your errors before you ship your code than it is to try and fix it after the fact. First of all, your reputation gets really harmed if you release bad code, whether you're a company or an individual. You just do not want to ship bad code. On top of that, you could actually do harm. You could lose someone's money. You could break someone's car. You could ruin the Internet of Things. You could expose the corporate internet to North Korean hackers. Who knows? All those things that should be fixed before deployment. JUnit, in particular, JUnit, J stands for Java. And we also call this a regression testing framework. And by regression testing framework, what I mean is I mean that we put a bunch of tests in place in our test class so that as I write new code, I make sure I don't regress. I make sure I don't go backwards and introduce new errors into things that were previously working. So as I wrote that add method and as I wrote that subtract method, I had a regression testing framework in place that I could run existing JUnit tests to make sure that when I added the add method and when I added the subtract method, I didn't regress and break code that was previously working. The only way I know that, well, I have confidence that that didn't happen because I have tests that test for that behavior. So it's called a regression testing framework to make sure you don't have regressive breaking of your code. It standardizes the testing process if we do it in Eclipse. These are automated tools that help us do the testing, so it helps us to do it very fast and very regularly. With a right click, you saw I could run the entire testing suite, and so it was very low overhead to make sure that I didn't introduce any errors. Very easy to use within Eclipse, once you know what you're doing, of course, but once you know what you're doing, it's very easy to build them and to run them. However, JUnit tests can be run outside of Eclipse from the command line if you want as well. It takes a little bit more effort, however, but if you want to do it in scripting, bash scripting or something, you can do it. These testing frameworks are critical for continuous deployment environments, for example, Jenkins and Travis continuous integration. If you don't know what those are, it's not super critical at this point, but if you do know what they are, testing becomes critical because a company like Google for Gmail has an entire process where code is automatically released to customers. A developer will write some code. There is a software mechanism that makes sure that other developers look at that code. And so it has to go through a couple checks. That's all managed automatically. And then once 3 developers has checked the code, it has to pass all the regression tests. And if it passes the regression tests and has other code developers review it, then it automatically gets pushed out to the website. It's a very continuous process. And last time I checked Gmail, the code that you run in the browser is getting released with new code every 2 weeks. Every 2 weeks, there's a fresh version of code that's coming out because of these automated procedures that are in place. Okay, JUnit is specifically for Java. The J stands for Java. You can see that you need to add an additional runtime framework in addition to the JRE in the project for it to work. There are, however, other unit testing frameworks for other languages. Every language has got them. So Python and R and I don't know, probably BASIC all have testing frameworks as well. JUnit in particular is open source. And by open source, we mean that it is free software. Unfortunately, in the English language, free has two important connotations. In the English language, free can mean that it is free as in freedom, or it can mean it is free as in it doesn't cost anything. And in the lingo of software developers, we mean free as in liberty or free as in beer, like beer that you drink. And the idea is that free as in beer means free beer is like you got the beer for free, but free as in liberty means it supports freedom. If you look at the term open source software as it is described in other languages, for example, Romance languages or Spanish, for example, open source software or free software is specified as being libre, which means freedom, the translation for free in English when you mean it in the sense of liberty, libre, or it can also be described as gratis, which means free is in the sense of not costing any money. So in other languages, these two ideas of open source software are specified in the language. We tend to say free and we're loose and typically American about it, and we don't know what we mean. But open source software is a whole philosophy of software that talks about enabling individual personal liberty. And it's an interesting philosophical framework for software that I encourage you to read about. It's not applicable for every single piece of software, but it is an important movement in the software industry that you should understand, but we're not going to cover today. Okay, so our unit test case is a particular piece of code that validates some code that the systems programmer has written to make sure that that production code, that method, that class works as expected. We do it quickly and efficiently by having a framework that helps us do it. The JUnit framework helps us do it. The key to writing a test is that a unit test has to have a known input, and we created those things when we created our constructor and gave it dollars and cents. And it has to have an expected output. We have to know by the design of our class what the output should be. And we have to have that worked out before we write the test and before we do our implementation, or we don't actually know what we're testing. If you don't have a design, you don't know how to test it, right? Like if you don't know what add should do, you don't know what the proper outcome should be. So you have to have that design in place before you can write a test. So that known input tests a known precondition for your code, and then expected output tests a known post condition for your code. You should know what by writing these tests, you know what the world is before you run your code, and you know what you want the world to be like after you run your code. Ideally, like we saw in our cases, you'd have enough test cases that all possible paths through your code would be tested. We saw that we had 100% coverage. In practice, for real code, there's never really enough time or money to do that leverage of code coverage, especially when code starts getting complicated and writing test cases becomes very elaborate. So an aim, a more reasonable aim is to get something like 70 to 80% test coverage and really focus on the important cases first. And you'll find that you'll capture a majority of your bugs just by aiming for that level of test coverage, rather than the 100% test coverage that I just demonstrated in the bank account and the amount class. 100% coverage meaning all my lines of code were colored green. In order to make sure that you have the JUnit testing framework installed in Eclipse, these are the steps that you go through. You highlight the project that you want the JUnit framework added to. You right-click on that project, and you go down to Build Path, meaning building the code. You select that, and you go over to Add Libraries, and that's going to drop you into the properties for your project. Your properties will show up, and you will need to add this library to your project. And you can see we already have JRE there, but you'll see some set of these. It changes depending on what plugins you have installed in Eclipse. But by default, you should have JUnit. So you want to select JUnit, hit Next, and then you want to check what version you have. JUnit 5 is the most recent version. There's no reason not to use JUnit 5 that I know of. So JUnit 5 is great. Hit Finish, and you'll see that the JUnit 5 framework is added to your class with the name JUnit 5, typically under the JRE system library. The only reason it's there is to validate code that you've written. And typically there's a one-to-one mapping between the code that you've written and the classes that you write to test it. Each class has a partner class that tests it. I'm almost done with this, so let me finish up. I know we're almost at the end of time. You're looking for that JUnit 5. You indicate a test by annotating your method with that @test annotation. And if you do that, the JUnit test framework knows that this is a test that it should run. There are many tests that you can run, and there is a URL there at the bottom that shows you all the different possible assert tests that you can do. You can assert that two things are equal. You can assert that some condition is false. You can assert that some reference is null or isn't null. You can assert that some condition is true. You can fail no matter what. For example, if you get to a certain point of code you never want to get to, a certain flow in your code. All those things are things that you can test for in your code and make sure that the outcome is what you expect it to be. This is an example of testing our counter class. It's very similar to what we just did in our bank account class. So I won't belabor it. There's some additional bits here if you get really into JUnit testing, which I kind of like, which are some repeated code that gets run before and after each test. If you need some help setting up an environment for your test, these are some methods that are available to you. We probably won't encounter those in these class, but I use them all the time when I'm writing code for research or otherwise. All right, so finally, just to reiterate, to run our test suite, what we do is we select the class or the method that we want to test. We choose Run As in order to select that we want to run that test. We choose Run As JUnit Test instead of Run As Java Application. That will be available to you if you have annotated it with the @test symbol. To see the results, you look down at the bottom under the JUnit Test panel. And if everything passed, you'll need to open the accordion to see all the things that actually got passed. In this case, everything passed. If you had some bug in your code and everything doesn't pass, then you'll see something color-coded here where it failed, and you'll get some details in the failure trace there about what exactly went wrong so that you can correct your test or your code. Finally, if you want to see code coverage for your test suite, you need to select the thing that you want to test, the test that you want to run, and instead of running it as, you select coverage as, and then you'll select your JUnit test. And when you do that, the same JUnit tests get run, but in addition to the JUnit tests running, you're also going to see the color coding in your source code indicating which lines ran. Now again, that color coding on your code is not indicating what failed, it's indicating where your code ran. The failures are only shown in that bottom panel. Just because it's colored red doesn't mean something failed, it just means that code wasn't executed. It's just something you have to learn about how the tool works. There's a semantic difference between those two things. Okay, that's it for today. That's JUnit testing. Thank you for your attention. Today for participation, which you can complete anytime before midnight tonight, is I want you to run the Eclipse code that we had today. I want you to run it as coverage as a JUnit test. I want to see the code colored red or green. I want you to take a screenshot of that and submit that screenshot. So for many of you, for those of you that are connected to Saros already, you should be able to do that in 2 seconds, but I know we're running late. So thank you for your attention. Sorry we ran late, a little bit glitchy at the beginning. Sometimes that happens. Stick around if you want to try and debug the Saros business, or we can tackle that in office hours. I will post both the slides for today, the YouTube link, and the code for today, and the Canvas module for today's lecture. So if you don't have time to stick around to debug stuff, you'll find all the source material there. Thank you. You are dismissed.